So here we're going to consider what is a classic AP Calc problem, and that is problems involving motion. So these are going to be problems involving position, velocity, acceleration. We've seen a few of these already this year. These make up anywhere from 15 to 20% of your AP Calc exam score, and they're a super helpful way to understand the derivative in real life, like everybody's seen their speed in a speedometer, and that's the types of questions we're considering. To tackle these questions, we're going to start with a really simple context that you've probably seen this situation in real life. So we're going to imagine a squirrel running along a telephone wire. So if I'm a squirrel on this wire, I can only move in two directions, right? I can move left or I can move right, but I can't move forwards or back because I'll fall off. So we're considering my squirrel moving in just one dimension here, just to simplify our work a little bit. And the first thing we're going to consider is our squirrel's position. So I give you this function s to represent the squirrel's position, and I ask you to plot its position at these times. So this is definitely just asking me to plug these in, and you can do that on your own. So s of 0 is 5, s of 2 is -3, s of 3 is -4. So plotting these is going to help us understand what we mean by position. So here's time 0. And then time 2 is over here at -3. And then time 3 is over here at -4. So over here at time 0, my squirrel starts all the way over here to the right and then runs over here to the left. So that brings us to our first definition. It's the definition of position. So position is distance, but it's distance from a certain spot. So it doesn't make sense to talk about where I am unless I have a point of reference, right? So in my example, s of 2 equals -3 means at time 2, the squirrel is 3 yards from the left to the left of the center of the wire, right? So 3 yards to the left of the origin. So negative values mean left, positive values mean right, and this has always been the case of how we imagine number lines and graphs, right? Then, my next question is find a function v of t for velocity. Well, you guys already know that velocity is the derivative of position. So to get that, I just use power rule. This is a very simple derivative to take. For more complicated ones, you could use the derivative function on your calculator. And then I'm going to graph it, and I have just a nice linear function, so I'm going to graph it down here in my graph. So it's a straight linear function going through 6 as my intercept with a slope of +2, right? And then here is the interpretation. Times that the squirrel is moving left and right. Well, I'm going to give you those, and you see if you can figure out why I picked these values. So the squirrel is moving left from 0 to 3, and the squirrel is moving right from 3 to 5. So the interpretation here is that the sign of the velocity function tells us which direction we're moving. So from 0 to 3, 0 to 3 is over here. The sign is negative, I'm moving left. 3 to 5, I'm moving right. The squirrel is at rest. Well, the squirrel is at rest when velocity is 0. So that would be at t equals 3. And then we have this notion of speed at t equals 1. Well, speed and velocity are kind of similar, right? So I'm going to start by plugging in 1. And then I get -4 when I plug that into v. But we don't usually say we're traveling -4 yards per second, right? So speed is the absolute value of velocity, and that's just a definition that you'll learn, is 4 yards per second. Okay, so now we have 3 definitions already: position, velocity, and speed. And then here comes one more, v prime of 1. Well, the derivative of v is 2, so v prime of 1 is 2. And my interpretation would be at t equals 1. Well, this is the rate of change of velocity, right? At t equals 1, velocity, the squirrel's velocity, is increasing at a rate of 2 yards per second, or per second squared. So if you've taken physics, That's going to sound familiar. This is called acceleration. It's the rate of change of velocity. Okay, so that's our fourth definition now. And here is the hardest question. And the question is the squirrel speeding up or slowing down at t equals 1? So t equals 1 would be this point on my velocity graph. So here, my velocity is negative, so my squirrel is moving to the left. But that value is increasing. So as time goes on, velocity is getting closer to 0. And this is hard to understand. The answer here is my squirrel is slowing down at t equals 1. And my justification is because velocity is negative and acceleration is positive. So they have opposite signs. And what that means is velocity is getting closer to 0. And we can see that on the graph, right? As time goes on, my squirrel's velocity is getting closer and closer to 0. So what that means, and this is hard to wrap your head around at first, is that the squirrel is still moving to the left on the wire, but it's slowing down, right? And at this point, that's when the squirrel turns around. So my velocity is 0 for a split second, and then he starts moving to the right. Again, hard to wrap your head around at first. You'll acquire that idea in time. For now, make sure your notes are really good so you have a reference to tackle those. So we're going to capture some important ideas here. And the first, deal with velocity. So 0 velocity means we're not moving, and then negative velocity means moving to the left. Positive means moving to the right on our squirrel power line problem. And then here's the thing that you really want to capture, because this is counterintuitive, because speed is defined with this absolute value, right? So whether we're speeding up or slowing down depends on both acceleration and velocity. Use this as a reference for now. So when they have the same sign, acceleration and velocity, so both positive, we say the object is speeding up. Same if they're both negative. If they have opposite signs, so one positive, one negative, we say the object is slowing down. And again, use this as a reference for those types of problems until you have it memorized, until you begin to develop an intuitive understanding. It has to do with the graph getting closer to 0. So that's all for this video. The remainder of the notes will be in the next video after your first AltaMath lesson.